Hey everybody, this is Larry. This is day 15 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and so forth. This is the third week. Welcome to the third week of August. You made it halfway. Let's keep going. Today's problem is minimum window substring. So I usually solve these live, so fast forward if you need to, if you find it slow or whatever you need to do. Or just watch it on 2x. Okay, so given S and T of M and N, okay, our two strings, okay, return the minimum substring such that every character in T is included in the window. If there's no substring, return the empty thing. Okay, what does that mean? Test cases is, there's a unique answer. Let's see. Algorithm that wants an O of M, but I think you have to, otherwise it just runs out of time, right? But okay, so there are a couple of ways to do it, but this is going to be anytime you see. I mean, well, this particular problem it even tells you window, right? So let's see. I was thinking about sliding windows, but can I even do it that way? Dun dun dun. Yeah, maybe. Yeah, I think I'm good to do it with sliding windows. I think you can also do it maybe another way. You can definitely do it another way, but I think sliding window is the way to go. I mean, there is a binary search way of maybe. But that's also like kind of sliding window, to be honest. So maybe not, or like sliding window without sliding window. So the idea about this problem is that and this is just sliding window in general. It's just trying to figure out an invariant, right? So first we want to find the first window where, for example, ABC is in this, and let's define this window by this thing so that this is the window, right? And then now. Now you can go either way, I think, which is that okay. So let me think about this for a second. This is kind of awkward. Because basically the idea is that you keep an invariant such that you move the right pointer and to yeah, so you add the right pointer. Well, this is not gonna be good. So yeah, so we remove A until the next character, so it's B to C. So now we're looking for A, but then yeah, because we shrink it and then we increase it. Okay, I think that's fair. That's going to get us the answer. In that way, it's kind of greedy in that, okay, now it goes to B, but then removes B, which means that it still has B, so that's good. And then now it removes again to B and then A, and then it goes to B. And now it sees that this is 4, so this is good. Okay. Yeah. I think so. That's basically it. Is that you basically want to sliding window takes it's kind of in a way to be brute force in a way that it's not the biggest brute force, but it just checks the substring in a way such that there's no other possibility that can be true. So that's basically the idea here, and the idea is okay. First, find the prefix in which all the characters in T is in S, and then here then you shrink it one to next character, and then here now you get B and C, but So you keep on shrinking until it no longer contains A, B, and C. And then now you're trying to keep on adding again until there's another one. So then now, basically these overlaps, the reason why these work is because at every particular point, there's this invariant, right? When you shrink things, you ask yourself, okay, I mean, you take a snapshot of it, you compare it to best or whatever to be like, hey, okay, this is a possible answer. Let's check it. And then you shrink it. When you shrink it, you go, yeah, when you shrink things, you basically try to figure out, because let's say now we shrink. What does shrinking mean? That means we remove the prefix from the candidates, and then now we ask, okay, what is the best possible answer, right? That contains A, B, and C. So then we keep on going to A, and then we shrink again on the left, shrink again on the left, and so forth. Because now we're saying, okay, we get rid of the prefix, and we still have a possible answer. Then that means that this is better than the previous one. So in a way, this is greedy into how you shrink and then how you expand. Because when you're shrinking, you're saying, okay, I can remove this character and still be true. And when you're expanding, you're saying, okay, I don't have a true statement, but when I expand, I can only have a solution, or it can only be at least as bad in that you don't have a true solution, or better in that you do have a true solution. So that's basically the idea behind the sliding window here. I'm going to start coding it, I think. But yeah, so then we have to think about how to implement this in a good way. Let's see, do we have to worry about... I'm just checking whether this is case sensitive. I know that contains upper and lower, but it doesn't tell you. I'll assume that they're different, and if I get it incorrect, then it is incorrect. So let's just say, yeah, okay. So we do a counter is equal to, so now we count the characters in T. How do I phrase this in a good way? So basically now we're starting from 0. So left is equal to right is equal to 0. And then now, because we don't have a true condition, we move to the right. We expand when we don't have a true condition. Okay. So let's just say we do this where n is less than length of s, and then here it assumes that we do not have a true condition. So we go. We also keep track of best is the shortest thing, and the shortest is going to be it could be this thing. So let's just do infinity, which is just some number that you can define. It doesn't really matter. And then here, so now we keep on expanding until we have every character. How do we keep track of having every character? I don't think you can. I mean, you could keep a delta thing, but I think there is. Yeah, I don't know if there's an easier way to do this in a O of 1 kind of way. But it's still going to be O of alpha, which should be fast enough. But maybe we can optimize this a little bit later. But we'll see. Okay, so here we expand right because we assume that we don't have T. And let me just double check that. Okay, it has at least one character on n, so we don't have to worry about empty cases, which is kind of always awkward. So that means that T sub, oh no, S sub right. So we do current. So now we increment the count by 1, right? And then now we see if the condition is met. If good of, let's just do this. Terrible naming, but that's fine maybe. But oh, not S and T. This is so current and counter. That means that current count that does counter contain or does current greater than or equal to counter, meaning that for every character that's in counter, it is in current and higher. So okay, so for x in counter dot keys, maybe I could do dot items. So this is the character and the count, and the if C is not in current, that means that current doesn't have that item, so let's remove it. So that's false. If current of C is less than X, then we also return false. Otherwise, return true. So maybe this is the part that I maybe we could figure out a rolling way to calculate, but maybe not. I don't know. So if this is good, then first of all, best is equal to max of min, because we're trying to minimize, of right minus left. Are we inclusive or exclusive? So let's make it, in this case, we want it to be exclusive because we start right off at 0, where that's no 0 as character, so it's just right minus left because this is an exclusive range. Yeah. Okay. And then we expand. Otherwise, if this is no good, then what happens? Oh wait, no, wait. Wait, maybe I'm saying this wrong. If this is good, well, we do this math, but we also actually gets to shrink it, right? Because now we want to shrink it because it means that we already have a possible solution, so adding things to it doesn't improve it. So yeah, so S sub left, and we subtract it from the current, and then we go again. Otherwise, if this is no good, then we do want to just increment, because then it gets checked if this is good here. I think that's pretty much it, to be honest. Maybe I've been off by 1, but let's run it real quick. Well, okay. Well, I have to actually return the answer, so hang on. I seems to have not misread the problem, but didn't return the right answer, but that's fine. That's weird. This should never be out of... Oh no. If this is good at the end, then S will go... Okay, so I did miss a case where if they're the same... No, that shouldn't. Maybe something is weird. Because if this is 0, then this should always be false, right? So, did I miss? Well, that's weird. So this should never go past. Left should never go past right in that case, because if left is equal to right, then current is empty. So that should be true. So maybe I'm weird something. Okay. I think I did this in a weird way though. So let's do that to be more explicit in what we do. Okay, so that's not so good though. Did I do the logic right? I might have missed the logic. Okay, so this is no good, so we add the current, we add 1, and then yeah, and then this is 1. Maybe I have to do this. Because this is, yeah, I do, because this is exclusive. I'm phrasing this, so I went off by 1 because I'm not phrasing this correctly. So we want these to be exclusive, then this should be true, but that means that this is not true because let me think about this. No, because if this is exclusive, then as soon as right oh. So if the end is not good, then we just break. I think that's actually. Because then now we want to add more to the right, but we just ran out of space. Otherwise, we do one more final check to keep going. So that's maybe why. Okay, so now we have the right-ish answer, except for not the actual answer. We can just, yeah. So if right minus left is less than best, we set best is equal to right. Oops, right minus left. Answer is equal to s of left right. I'm always really bad at off by 1. So let's see if this is correct. At least in the indexes, because a lot of different languages use different indexing for this substring stuff. So I'm really I get really bad about it. But this looks pretty okay. So let's give it a spin. Am I confident? The test case has multiple solutions. Really? I guess just these two. Okay, fine. Also, let me check the case where it's uppercase. Let's see if it's case sensitive. Because if this is not case sensitive, it would have multiple answers. So, okay. So let's give it a submit. See how that goes. Okay, cool. So as you can see, this is kind of linear time, except that this part, as we said, is going to be O of alpha, where alpha is less than 52 because of uppercase and lowercase. And this loop is going to be O of n. Why is this O of n? Because right increments and times, and left increments n times. So that means that at most this loop is going to happen 2 times n, which is O of n. So this, and each of these O of n loops will make one good function to good, and that means that this is actually O of alpha times n times. In terms of space, this is actually O of alpha space, and this is easier to see because we use counter, 2 counters, and of course this is just to keep track of all the alpha bits. So you can actually even have 2 arrays if you like, but those 2 arrays will always have 52 elements, or at most 52 elements. So this is going to be O of alpha. Yeah. So this is a sliding window. It's a little bit tricky. It's a little bit awkward. Definitely practice stuff like this. But a core part of a lot of sliding window problems is that it is greedy. So you have to practice a lot of greedy solutions because it's really hard to prove a greedy solution for me anyway. So I do it from experience instead. So I don't know. Let me know what you think. Let me know how you did. And yeah, stay good, stay healthy. Happy Sunday. To good mental health, and have a great weekend. I'll see you later. Bye bye.